Dear students, welcome to the next session. The topic of today's session is Relational Algebra. At the end of this session, you should be able to summarize the various relational algebra operations that can be applied on the relational databases. First of all, let us discuss what is meant by a relational operation. All the procedural and relational query languages provide a set of operations that can be applied on either a single relation or a pair of relations. So one particular query language that we are going to discuss in the rest of the syllabus is SQL, that is structured query language, and all these operations that we are going to discuss can be applied with the help of SQL also. So these query languages allows us that these operations can be applied on a single relation or a pair of relations. And these relations have a specified or desired property that their result is always a single relation. Whatever the operation that you apply on either a single relation or a pair of relations, the result that you are going to get is a single relation, that is a single table. This property allows us to combine several of these operations in a modular way. That is, since the result of the relational query is itself a relation, these relational operations can be applied to the results of the queries as well as the given set of relations. You can apply these queries on the result of the queries also. Let us discuss one example. The frequent operation that is applied is the selection of specific tuples from a single relation. That for example here you have the instructor relation that you are going to select the tuples that satisfy some predicate means the condition that those instructors who are getting the salary above 85,000. The result is a new relation that is a subset of the original instructor relation. For example, this is the original relation where you have the ID, name, department and salary, and your objective is to select those tuples that having the salary above 85,000. So the result will be like this. So this will fetch you a new subset of the original relation which is having the salary above 85,000. So this is an example for selection operation, which is a horizontal type of select. And the next is a vertical select, where to select certain attributes, that is the columns from a relation. We may be interested in getting only the IDs and the salaries without listing the name and the department name from the instructor relation. So this will fetch you the result like this. Only the ID and salary will be fetched from this particular original relation. So this is an example of vertical select. Each tuple in the result is derived from the tuple of the instructor relation, but only with the selected attributes. This is an example for vertical select. The next is a join operation. As the name suggests, this is combining of two relations by merging the pair of tuples, one from each relation, into a single tuple. Here is example like joining the tuples from instructor and the department. So we have joined. So this is called as natural join. A tuple from instructor relation matches a tuple in the department relation, and if the values of the department name attributes are same. You have department name in both the instructor relation and the department relation, and when you have a match in the department name in both of these relations, then those tuples will be matched and that will be the result. So this is the result after joining the instructor and the department relations. So we'll be having the fundamental operations in relational algebra. So these relational algebra operations are applied on relational databases. So we have the fundamental operations like selection and projection, and the Cartesian product, union, set difference. So these are the fundamental operations. Together with that, we have some more operations like join, intersection and division operations. We'll discuss one by one. Now it is the selection operation. So this is indicated as a notation like sigma. Sigma stands for selection, and we have the predicate, which is the condition upon which the selection has to be occurred, and R stands for the relation upon which the selection occurs. The selection operation works on a single tuple R and defines a relation as a result that contains only those tuples of R that satisfies the given predicate or the condition. So the notation is sigma p of r. R is the original relation, p is the condition, and sigma is the notation for selection. As an example, list all staff with a salary greater than 10,000. So we are going to express this like sigma salary greater than 10,000 on staff. Staff is the relation. So this selects the tuples from staff where the salary is greater than 10,000. So you have original database which consists of the staff database consisting of staff number, first name, last name, etc. And from this you are going to select only those tuples having the salary greater than 10,000. So this is the work of selection operation. So you could see that those salary which are above 10,000 or those tuples only are listed here. So this is the output of the selection operation. The next is the projection operation. The projection operation, it is indicated by pi. The mathematical letter pi. So this works on a single relation and defines a relation that consists of the vertical subset of R, extracting only those attributes which are specified. Here the notation goes like this. You are going to select the attributes a1, a2, an, whatever may be the attributes that you require on the particular relation R. So this selection works like horizontally. It will select the tuples. Whereas the projection works vertically, it will take only the columns, required columns. Selection and projection operations extract information from only one relation, that is more important. Example, so produce a list of salaries from all staff showing only the staff name, first name, staff number, first name, last name, and salary details. So this you are going to project it, project only the required attributes on staff. So from staff, you are going to only list out the staff number, first name, last name, and the salary. So this is the output of the projection operation. So we are going to consider two relations, branch and property for rent, for the rest of the operations. So you could see that branch is a relation consisting of 4 attributes: branch number, street, city, and postcode, and property for rent. So this stands for the relation consisting of whatever the properties that are given for rent, and who is the owner of that property, and who is the staff number who is going to oversee that property. So this is the two relations that we are going to consider in the rest of the operations. First is union. Union, as it is similar to the set operation union. So this is going to combine the tuples of R and S which are present in R and or S, or both R and S, and the duplicate tuples will be eliminated. So R is a relation, S is a relation, union represented by U. For example, you can indicate like this: project only those authors who are present in books and the authors who are present in articles. So you have two relations, books and articles, and you are going to project only the authors and you are going to combine. So after projecting the authors, and you are going to combine the authors who are all present in books, articles, or both, and the duplicates will be eliminated. So from the given example, like branch and the property for rent, I have listed only those cities which are present in branch and the properties for rent relation. So the union, it is going to combine attributes from two relations. Intersection, as you all know, it will be having as output only those tuples which are common in both the relations. That is intersection. Intersection operation performs set intersection of two similarly structured tables. Only from two similarly structured tables you can apply intersection. So this query, it is going to project the city which is common in both branch and property for rent. So list all cities where there is both a branch office and at least one property for rent. So only when the city occurs in both the relations, it will be appearing in the result. Intersection based on city attribute from the branch and the property for rent relation. So this intersection stands for common attributes. The next is set difference. Set difference operation defines a relation consisting of the tuples that are in relation R but not in relation S, and both these has to be union compatible. So this has to be similar structure, that is what union compatible. Tuples which are present in one relation but not in the second relation. That is the result of set difference. And the notation is R minus S. For example, find all tuples that are present in R but not in S. If a tuple is present only in R, that will be listed, but if it is present in S, that will not be listed. That is the objective of set difference. Example in the branch and property for rent, minus. So this lists all cities where there is a branch but there is no property for rent. The tuple has to appear in the branch but not in property for rent. Only those cities which are present only in branch relation, that will be listed here. So this is the output of the set difference based on the city attribute from the branch and the property for rent relations. The next is Cartesian product. The Cartesian product operation defines a relation, that is concatenation of every tuple of R with every tuple of S. One tuple from the relation R will be taken, that will be combined with every tuple of S. The next relation, next tuple from R combined with all tuples of S. Similarly, it goes on. For example, you have one relation which is having name and roll number and another relation having department ID and department name. The output of the Cartesian product will be A1 from first relation combined with 11CS 12IT. You could see here. B combined with both the tuples of B relation, and C combined with 11CS and 1280. So when you have 3 tuples in one relation and 2 in the other relation, you will get 3 into 2, that is 6 tuples in the Cartesian product. Every tuple of first relation will be combined with every tuple of next relation. So when you have two relations R and S, union combines every tuple of R with S, eliminating the duplicates. Here you could see that E5, E4. So these are different tuples. So that will not be considered as duplicates. Difference means that those tuples from R which are not in S, that will be listed here. S difference R means that every tuple of S that is not present in R. R intersection S, that gives you those which are common in both the relations. So this is cross, which means that it is Cartesian product. Every tuple of R combined with each and every tuple of S. That is the result of Cartesian product. So we have mentioned that these operations can be applied on the result of the operations also. So that is what relational algebra means. So we can perform operations on the result of the queries also. If you want to find the ID and salary for those instructors who have salary greater than 85,000. So this is a combination of two things. So first you want to find who are all the instructors having the salary greater than 85,000, and then after selecting those tuples, you want to list only the ID and the salary of the selected. So this has to be applied on the result of the first query. First we select those tuples from the instructor relation where the salary is greater than 85,000. So out of the result, after that result, you are going to select those two attributes, ID and the salary. So which means that you can apply the relational algebra operations on the result of the queries also. Summary: the relational algebra defines a set of operations on relations, paralleling the usable algebraic operations. So these operations of relational algebra are similar to algebraic operations applied on mathematics like addition, subtraction, multiplication, which operates on numbers. Just as algebraic operations on numbers take one or more inputs, numbers as input, and return a number as output, this relational algebra operations also take one relation or two relations as input and returns a single relation as output. So this is where this relational algebra and the algebraic operations correlate. So this is a summary. We have discussed selection, sigma. So this is going to return the rows or the tuples that satisfies the given predicate or the condition. And we have projection, that is used to project or output the specified attributes from all rows and removes the duplicate tuples from the output. The next is join, which is going to combine two relations based on an attribute which is common in both the things, like instructor and department. When the department name is same in both the things, then that will be displayed. Cartesian product, it simply combines all the tuples of one particular relation with all other tuples of the next relation. Union, this is going to output the tuples which are present in one relation or two relation or both relations. So this is the reference book, you can refer it. Thank you for your patient listening.